boxed in. They are boxed in red. You can see that here on the map. And 3 of them, Chalmers Industry Technique, Thema Solutions, and IDEA Consult, will actually be represented here by speakers. And Tobias Stöger and myself from the Helmholtz Center Munich are coordinating this endeavor. So Harmless Project website is also noted. Let's move to the next slide, please. So just a few words of motivation why safe and sustainable by design may be an issue in the near future. There's some activities on the EU level and on the OECD level and on other levels. So you probably are aware of the Green Deal, which has been announced recently by the European Commission, and it has several components. One is the EU Action Plan towards the zero pollution for air, waste, and soil. Then there is a circular economy action plan and an EU chemical strategy for sustainability towards a toxic-free environment. And what that ultimately amounts to is like a pre-market approach to chemicals to avoid volumes and chemical properties in the interest of lowering harm to human health and the environment. And then we also have now, this is just on chemicals, but there's also a thrust to include materials into this. So there is now a safe and sustainable by design framework introduced by the Joint Research Center in Ispra, Italy. It was published in July 22, and it is now under public consultation for 2 years. So it started in March, so there is still time to communicate your comments on this. And of course, it has safe and sustainable by design, but it extends from chemicals and to materials. And it represents a framework for the definition of criteria and evaluation procedure for chemicals and materials. It is not a regulation or legislation, but it is a guidance to support and stimulate innovation in Europe. And as I said, there's a stakeholder consultation going on right now. Just go to the website I indicated above to find that, if you want to comment. Of course, our safe and sustainable by design framework is aligned with the Joint Research Center approach, but as I said, there is discussion going on, so it's not final yet. So it's important that you get involved now, figure out what's going on, and see how it serves your interest and needs. And finally, also on the OECD level, there's activities specifically from the Working Party on manufactured nanomaterials. They have formed a new steering group on advanced materials. And since we will use the term advanced materials quite frequently, I would like to give an explanation for what is meant by that. There is no official definition out there. This is also under discussion what this term refers to. But according to the steering group on advanced materials, it is a material that is rationally designed. So it is not waste, for example, has to be rationally designed, and it would have a new or enhanced property as compared to conventional materials. And it has a targeted or enhanced structural feature. And obviously, ultimately, it is designed to achieve specific or improved functional performance. And this is always referenced to a conventional material. Yeah, next slide. So with this, what we will have on our agenda today can be summarized in 2 terms. We will give you an introduction into the harmless approach to integration of safe and sustainable by design principles in the context of AdMa enhanced product development. And there we have 4 presentations for you. We first start with easy steps towards safe and sustainable by design. This will be also a guidance for avoiding obvious risks with nanomaterials. This will be presented by Michael Persson from Chalmers Industry Technique. And the second presentation will be on giving an overview on the safe and sustainable by design framework and the decision support system, which goes along with that, will be presented by Blanca Suarez from Tema Solution and from Susanne Deckers from TNO. And finally, we have an AI-based data acquisition tool, present that to you and show how this is integrated into existing databases. This will be presented by Nina Yelyaskova from IDEA Consult. Then, of course, we have a wrap-up and the most important thing, questions and answers and discussions with you, but I will get to that later. And ultimately, the second part is, from our perspective, the most important one, because we really want to make the safe and sustainable by design framework work, not just for industry, but also for small and medium enterprises. And I really hope that you take this as an opportunity to get involved with us, help us to make it better and more suitable for small and medium enterprises. And hopefully along the way, we can also help you and facilitate your business one way or the other. Yeah, with that, we'll go into the first presentation by Mikael Persson.
Thank you, Otmar, and I hope you can all hear me well. As you can see from the title, I will talk about easy steps towards safe and sustainable by design and give you some guidance how to avoid some obvious risks. And this will be very much based on my experiences from industry and industrial development and cooperation. So first, I will come back to a little bit more about my background. I will talk a little bit short about safe and sustainable by design, and a little bit why should an industry participate in this type of activities, and in what way that can be valuable for us, and then try to summarize this type of experiences and what type of thumb rules I have learned during all the years. So my background is from, worked for about 10 years in a research institute with advanced ceramics. And you see the bullet here. So I worked a lot with submicron particles, meaning also particles go into the nano range. I work with metal oxide salts, yttria, zirconia, alumina, silica, nanoparticles really. But when we really went into the area of whiskers, that is single crystals, needle-like particles, then we really started to consider safety. And we saw that it was too similar to asbestos. And this was in the mid-80s. And then it was used for making ceramic composites at that time. And then due to our conclusions, we actually really rebuilt a lab and changed everything from floor and the furniture. Everything was changed, the ventilation and so on, in order to be able to reduce the risk for us working with the materials. And then after about 10 years, I joined the big industry, large industry, where I've been about 30 years. And one of my main focus areas was products for the paper industry. I mean, this was the chemical industry belonging to the Nobel Industries Group in Sweden, later on become part of AkzoNobel, Specialty Chemicals, and the last years has been under a new name, Nouryon. And I've been looking at a lot about colloidal silicas, and you see some images here to the right. And mainly I focus on these very small elongated structures in the nanoscale, which is used actually in paper production to improve both productivity and quality. And the interesting thing to work with paper industry as a customer is that they have very high demands, both on performance, but also on the safety aspects. I mean, some of the cardboards are used for packaging for food. And then there shouldn't be any migration of toxic substances from chemicals or particles. So that has been a very important aspect. And now, after more than 40 years, I am working at the Chalmers Industry Technique, where I'm helping SMEs in process and product development, and many of them in the nano area. So please, next slide. And just some simple words about safe and sustainable by design. What is this all about? To make it very simple, I think safety, it's a function of what type of hazard, meaning that toxicity of the materials you have. Also, what is the risk for exposure? If you have a very low hazard, the risk will be low. If you have very low or no exposure, of course, the risk will be low. But if you have some degree of exposure with hazardous materials, of course, you have a problem that you have to face and analyze more in depth. Sustainability, I think, talking about nanomaterials that is safe can be a very efficient tool for creating sustainable solution. So it's all about doing more with less, both materials and energy and so forth. Please, next slide. So why should, industries participate in this type of activities? For me, as a former innovation manager at Norion, for me, innovation was very strongly linked to sustainability and safety. So it's all about to make the innovation as large and profitable as possible, and also a way to, if you consider sustainability and safety, to risk minimize your business. So it's a very, for me, very much driven from the business ideas of your concept and production, etc. And the good thing with these type of activities, you can also get some early warnings, which you can use to avoid certain areas that will be more and more problematic, and where maybe also regulations will come that will stop you from using certain materials. So from my perspective, I've been working with amorphous silicon nanoparticles in 30 years. We used to say that those particles are safe to use, but only in the recommended applications. But we also say that if you start with some minor modifications, that may change the risks of the materials. I mean, it can be increased risk or reduced risk. And every new applications have new demands. So in some applications, maybe you don't need to consider safe and sustainability by design, but in some, maybe you have to work really hard in order to fulfill all the requirements. And also finally, that, I mean, colloidal silica, as we saw, it has some technical weaknesses. But now I understand some of these weaknesses can also be a strength regarding the safety aspect. Like, for instance, colloidal silica, I mean, it's amorphous, that is maybe not a weakness, but solubility can be a weakness in some cases. But from a life cycle perspective, it's good that the particles will be completely dissolved, depending on the condition. And irreversible aggregation means that the risk for inhalation of dry powder or dry particles will be reduced. Okay, please, next picture. And this is an overview of the industrial cases we have in Harmless right now. I will not go into depth, but here we have all possible, you can say, application areas like paper making, the paint formulation, catalysis, facade insulation, agriculture. And also we have advanced materials consisting of different types of metals. We have high aspect ratio nanomaterials, complex formulation, etc. Okay, but please make next slide. Yeah, and this is just a try from my side and my experience is to give you some very simple advice and some thumb rules. A simple way, I mean, of looking at nanomaterials can be you can talk about traditional or conventional nanomaterials, which AdMa just mentioned. And here, I mean, the reason why it is green here is that then we have a lot of experiences there, a lot of data where you can look at and really get an understanding of the potential risk. But as soon as you move into the other areas here, number 2 and 3, I mean, if you take a traditional materials that you are for the first time produced as the materials, new things may happen because very small particles, for instance, with a high surface area, can interact in a completely new way you couldn't really consider from the more traditional macro type of materials. And of course, when you go into new materials, advanced materials, where you have different types of functionality and feature and risk for release. Of course, this is a new case where you have to consider the risks more in depth. And just to remember, even a minor modification may change the risk. It can be reduced or increased. So the general chemical composition doesn't give you any guidance really. It's about very much about the surface also. So next slide, please. And this is really what I'm based, if I try to condense my 40 years of experiences on different material properties and risk. Some kind of thumb rules, and the idea is here, if you look at the more left-hand side, I mean, if you have more amorphous type of, say, particles, spherical, they are more soluble, hydrophilic, non-ionic, anionic maybe, and if you have them in liquid dispersion, you're more on the safe side. If you totally are more on the other side here, I mean, they are more crystalline type of particles, especially talk about silica, high aspect ratio, fiber-like or harm, inert, stable, potentially that could release toxic ions, more hydrophobic, cationic or dry powder. There you have, more of the risk that you should maybe look deeper into the potential risk and what you can do about it. I mean, dry powder is obvious. I mean, then you have the risk for inhalable dust, for instance, which you don't have to the same extent if you keep everything wet. And next slide, please. Next slide. Oh, thank you. This is just a summary of my 30 years working with colloidal silica, which I think have some examples why this is where we have the risk or exposure really under control. I mean, first of all, you have a production that is a closed and also wet process using water, which is quite a nice and cheap environmental friendly solvent. All the shipping handling is liquid dispersion, like in this image you can show you. And the customers also handling it wet. You have a very low level of inhalable dust. And also in end-of-life aspect, I mean, that you have an irreversible aggregation. You can't get a nanoparticle bed after drying. There can be weakness from technical point of view. I see it as a strength from a sustainability point of view. And that the material can also dissolve if you have it heavily diluted. And from a hazard point of view, in our example here in HARMLESS with the paint formulation, we can see that, I mean, the surface modification is a very good tool to, in this case, improve the performance in the paint. But it also shows to be very efficient to reduce toxicity, even if that was not the first reason why we looked into this. And it's just a simple silane modification of silica where you only use maybe 20% of the available silanol groups on the surface, and still you get a very good effect on toxicity. So I think this was my last slide, and as you know, we keep all the questions to the end, and now Blanca from Temasol will start. Thank you.
Thank you very much, Michael. So now I'm going to talk about our harmless, safe and sustainable by design framework. Can I have the next one, please? Yes. But before this, I just wanted to go one step back and remind all of us why safe and sustainable by design have been sort of often linked with the development of nanomaterials and now advanced materials. And this is because already, in my experience 10 years ago, we already realized that some of the drivers that lead into toxicity in chemicals are not really met in the case of nanomaterials, because our testing guidelines for safety are based on mass. So we add a certain amount of chemical into our cells or our experiments. In the case of nanomaterials, in those days, we realized that toxicity was driven sometimes by physical-chemical characteristics, such as shape or charge, coatings. This has already been presented by Michael. Not even that, and also depending on the surrounding media where our nanomaterials were in, we will also have modifications in our materials, what we call system-dependent toxicity. And I will give an example of this. Can I have next one, please, and the next? And here you can see two microscopic pictures of nanosilver, 20 nanometers in size. To the left, you can see the nanosilver nicely dispersed in the aqueous media without serum. This is without proteins. And you can see here how we can identify individual particles. If we go into the picture on the right, here we see our very same particles, silver particles, dispersed in aqueous media with proteins. And here you can see big aggregates. So we can already anticipate that if we were to use these samples on our toxicology experiments, we'll get different outcomes. So it's not that the material has changed, but it has changed, but because of the environment where it was in. Proteins will attach to the particles and form what is called a protein corona, which will help them to stick to each other. So yes, so if we can already anticipate which physicochemical parameters are driving our toxicity, we could already design them out from our particles. And can I have the next one, please? And this will give us a really very good opportunity to implement safe and sustainable by design, because otherwise we can have so many different types of particles, we can vary the size, the shape, etc., and testing will be really economically not viable. Can I have the next one, please? I also wanted to introduce to you what safe and sustainable by design is not. It's not a risk management exercise. So we are actually, before this, we are at the prevention state. We want to design chemicals which are clean and recyclable. We want to design clean processes and chemicals which do not cause any harm in the environment and humans. If we are into the risk management phase, this is also part of safe and sustainable by design, but we have already identified here a risk, and we need to, for example, minimize the risk by minimizing exposure. So even if risk management could be part of safe and sustainable by design, it's not only safe and sustainable by design. Can we have the next one? Yeah. So here is our safe and sustainable by design process in a nutshell. And I wanted to introduce this to you to see how we are moving away from our standard way of working. So generally in our experience as consultants, companies will have an idea to develop an innovative material. And first they will develop their material, and then they will come to us for consultancy on regulatory issues at the at least prototype stage, when they already have some materials which are tangible. And then we look together towards regulation, regulatory compliance, and then products can be launched on the market. In some cases, rare cases, we can find what you can see here on top, the high risk, high cost approach, where products first reach the market before a regulatory compliance exercise have been performed. And in this case, often products have to be withdrawn from the market. This could also happen when a company wants to change the sector of their material. So they have regulatory compliance to one sector, for example, cosmetics, and they want to move into a medical device. This is just an example. So what we are trying to do here in Harmless, together with other EU initiatives, is to go towards the low risk, low cost approach that you can see at the bottom of this slide, where safety is already integrated from the beginning into the product innovation phases. You can see also here another picture to the right on the agile innovation management, because the small companies so often don't follow a linear innovation process, but they run parallel processes. So not to bet everything to one horse, so to say, but to have alternative prototypes. And then at the end of the day, they will go for the best looking one. But this is only just for you to tell you that not all innovation processes are linear, like you can see here. Can we have the next one, please? So if we zoom into this innovation process, here you can see the Cooper stage gate model, which is divided into 5 stages and 5 gates. And the idea is to identify the set of criteria per stage. So when we go into a gate, we can have a look at what we have regarding our criteria on safety, sustainability, and functionality. And if we meet this criteria, we can go ahead. If not, we need to rethink some of the issues on our materials. Some criteria are no-go criteria. They will give us a red light. Other criteria allow us to continue, but we have to bear in mind that some issue may come up later. In the Harmless project, we have made this innovation process a little bit leaner. So we have fused the ideation and screening phase, and we have also fused the pilot and launch phase. So our innovation process in Harmless has 3 stages rather than 5. I also have here the use and end of life at the beginning, at the ideation stage, because if we don't think about this at the beginning, we won't be able to implement recycle strategies at the end of our innovation process. Can I have the next one, please? So again, zooming into further in the innovation process, you can see already here our Harmless innovation process. Going from idea into the pilot scale prior to product market launch. And in Harmless, to achieve the different set of criteria, we have already identified a set of tools. Of course, in the beginning, at the ideation stage, we won't have data. And sometimes we have to look for similar materials or compare our future material to the current materials, and we call grouping approaches to try to extrapolate data from the materials we already have. We will find out more about this at the last presentation today by Nina. So as you can see here, we start with qualitative methods, which will give us qualitative information. But as we are going along the line, when we will end up on more quantitative methods, at the lab scale, for example, we already have a prototype, and we can test this prototype with the cost-efficient tools like with the cell cultures, and already gather information which can tell us what is to come later. Of course, at the end, at the pilot scale, we'll have to follow OECD guidelines, which are regulatory approved, and our data will be more quantitative. So all this structure that you can see in this slide actually has to become an actual product that people can use, some tangible product. And this will be introduced later on by Susan Deckers, who they are developing our decision support system, which is based on the concept that I am now explaining to you. And can I have the next one, please? So again, looking into the Harmless, safe and sustainable by design framework, we follow very closely the JRC framework, and that means that per different stage, we need to identify a set of criteria, looking into the 5 different pillars that the Commission has identified. That is the intrinsic hazard, occupational safety, consumer safety, environmental safety, and sustainability. So all these pillars are considered per stage, but of course the amount of data will be different if we are earlier in the process or we are later on in the process. And these criteria will help us make decisions towards our final material. Can I have the next one, please? Finally, sustainability is also very important. And as I mentioned before, we have a sustainability module in our framework. This module has been developed via a set of questionnaires. Questionnaires have different data demands depending on where we are at the innovation stage, but they are very easy to implement. We try to develop these questionnaires in a way that the questions can be answered just by the company. They don't have to seek information from toxicologists or risk assessors or sustainability consultants, because we know small companies don't have this expertise. And our questionnaires, again, are also inspired in the safe and sustainable by design framework criteria from the Commission. So we will try to gather information regarding elements such as environmental sustainability, sustainable use of natural resources, energy efficiency, pollution prevention, supply chain and circularity, following the JRC framework. Of course, this is not a new approach. Large companies, like you can see here, the BASF company already launched back in the 90s what they call the eco-efficiency analysis. where they want to they seek to calculate ecological impact of the different solutions during the life cycle of the material, also including costs. So then at the end of the exercise, you can have a spider graph like you can see below, where you can compare your solution to alternative solutions and go for the most suitable one, also taking into account cost. However, this process to us is quite time consuming and data demanding. So for our harmless framework, we try to make some linear approach. And with this, I think this was my last slide. I will now give the floor to Susan Deckers, who will introduce us to the decision support system, which actually is the tool to implement the concept that I have just explained. Thank you so much.
Thank you, Blanca. So I'll tell you a little bit more about the decision support system. Next slide, please. Well, the objective is to build something that's very user-friendly, also useful for SMEs. And it is, of course, based on what has just been explained by Blanca, the Safe by Design framework that's developed within HARMLESS. It should be able to handle advanced materials, advanced nanomaterials, I should say, so high aspect ratio materials, and also multi-component nanomaterials. In the decision support system, we use existing but also newly generated data that's generated within HARMLESS, and not only data but also existing. We also try to integrate these data and models as much as possible to make it leaner, and we test it with case studies and try to improve it with the insight, also gathering your feedback, for example, on the decision support system. Next slide, please. So it is based on the framework. Here is a more elaborate picture of the one that Blanca just showed. It follows the innovation stages, the 3 that were explained, starting on more qualitative assessment, moving into more quantitative assessment once you progress in your design phase. And it also stages, so the production manufacturing, but also the use and the end of life are taken into account in each of the phases, although with different types of information. So moving through, you continuously develop 100. All right, now we are recorded again. So probably you missed a little bit if you're watching the recording, but I continue anyway. So if you look on the right side on the circle, you can see the point estimate of each of the aspects, which is the black line. And it moves from 0 to up to 100, indicating 0 is fine, and up to 100 will be a higher risk. And then you have what is now the light blue bar, giving the uncertainty surrounding this point estimate. We also want to get this a more color coding, yellow, orange, green in the next version of the decision support system. So here gives you more insight also into the uncertainty. Next slide, please. So yeah, it's under development, and we want to make it as easy to use as possible, following the different innovation stages, and yeah, starting with limited information and limited or easy to use data and methods, going into more comprehensive data and methods when you go more to market launch, closer to market launch. It also includes the uncertainty, and we're trying to integrate the data and the knowledge that is available. First, to reduce the number of questions or input parameters for the user, but also to get a better prediction and reduce the uncertainty around the prediction. And also, we're going to use similarity assessment and read across and incorporate in this way existing knowledge into the decision support system and the outcomes. So to be able to use what's out there already. And with that, it's really important data availability and findability. And I can introduce you now to Nina, who can tell a little bit more about that as well. Please, Nina, go ahead.
Thank you, Susan. I would like to present a system we have been developed and use it since a while for integrating data from many EU-funded projects, but not only, and some recent additions which make use of popular AI models. First, the presentation is mostly focused on the nanosafety data interface to eNanoMapper databases. We also mention other sources like rich dossiers, and we are aware of a lot of data in chemical structure databases like PubChem and also material databases. With all these sources, the usual challenge is how do we find what is relevant for new material under development, what materials are related to the new material, or maybe it's existing material with slight modifications, and also what data might be relevant. Next slide, please. I'd like to introduce, for those who are not aware of, the nanosafety data interface, which is an online user interface aggregating over 20 eNanoMapper database instances. It's available at search.data.eNanoMapper.net. Some of the instances are publicly available, and some are only accessible to project partners so far. This is usually until the project decides that the data is going to be open. Usually after the end of the project. We have this Nature Nanotechnology paper from 2021, which describes the system as well as data available at that time coming from NanoRec2 database. Now we have a lot of more data in the database, and the actual database system which is behind is an open source, which have been designed over many years with industry help as well. Next slide, please. Or there is animation. I would also like to stress that in European Observatory of Nanomaterials, there is a section on eNanoMapper, which is using the same backend open source software for data management, and the same JavaScript library for presenting the results, but it's integrated in the EU web page. The data is somewhat outdated, but I hope this could be updated soon. Next slide, please. What's available in the system? We have open metadata, which is slightly not readable in the bottom left corner. And what is zoomed on the slide is availability for toxicity data. We can see, and the color code is the material types, like silicon dioxide, titanium dioxide, etc. Then when you see a filled in cell, that means we have data. First row is cell viability, and etc. As one can see, we don't have all types of the data for all the materials, so it's usually a challenge to make use of these data because of the sparsity. On the other hand, there's already a lot of data, and this is only toxicity. Next slide, please. For FISChem, the dashboard, there is a dashboard section in the nanosafety data interface, which provides many different visual summaries. This is one of the examples I'm showing on the screen. Histogram of FISChem characterization. What is zoomed is a measurement from DLS. Again, color code is material types and the number of materials and what is the value, binary value of the PDI index. So this is a quick overview of actual physical characterization, FISChem characterization of the materials. Next slide, please. Another dashboard option is to explore the composition of the materials as measured by different techniques, which the three bar charts are different techniques measuring the same chemicals, and you could see how well elements are measured by different techniques. On the y-axis, we have materials, and the actual measurement on x-axis. The actual composition dashboard is interactive, so you could zoom in and explore further. Next slide, please. Finally, we're trying to provide a bird's eye overview of the data in the database with so-called material fingerprints. We can, on the x-axis, you see different materials, not types of the material, but actual materials. This is exactly data comes from Gracious database, which is now publicly available from Horizon 2020 Gracious project. And on the y-axis, we have different methods and different measurement techniques. And to be able to plot them on the same chart, we plot not the actual quantities, but the distribution, where they go into the distribution. So this is the color code is quantized. So if you have red color, this means the value is in the high range of the materials. So we have on the left, the first row is ferrite minimal diameter, and we have a couple of pigments on the left of the x-axis. So you see they have a rather high diameter, and where is blue, this is the low range of particular property. Next slide, please. Now this is all data about safety, and we typically don't have data on functionality in this database, which is a pity, but it's understandable, as functionality data is usually the know-how and the material providers or material designers. And we decided to use the popular, lately popular large language models to retrieve data from purely typing the name of the material. So you could type in graphene oxide amine functionalized, and you'll get the first row of the bottom part of this chart, which is the material class, 2D nanomaterials, what is the functionality, what is the product class, where it's used, what are the benefits of a conventional material if it's a new one, what is composed of particles, fibers, platelets, whether it's nano material or nano enabled or not at all. So in principle, this type of automatic classification can help you answer the first 4 questions Susan was just presenting. Next slide, please. If you're looking into the classes of materials and not particular materials, we have similar functionality, which the description of the classes and subclasses of the materials are already retrieved by AI tool, and you could explore, for example, what's shown on the screen is plastics as a top class and subclass of bio-based plastic, biodegrading plastic, etc. You see some of the plastic are considered advanced materials, some are not. And there's also description on the functionality, properties, application, etc. Next slide, please. Now with all this data on our fingertips, we'd like to help you by providing more overwhelming system of finding materials or class of interest, and search in combined databases, not only nanomapper but also others, and eventually predicting properties for the new and existing materials where we lack measurements. So what you see on the left is same screen as on the previous slide, but this time focused on graphene. So you could search and find all classes which are relevant for graphene. And for example, if you have the goal of designing functionalization of graphene, what we can help with is to derive a model where we can predict to a certain extent properties of graphene functionalized with novel compounds. And what you see on the screen is the small dots data from rich dossiers, and from the nanomapper database and the new materials large dots. Colored dots means we have data for particular property, which is not shown on this screen, but again, the legend is that red is high and blue is low. And for those large dots which we don't have data, these are the ones we want to predict, and we can actually predict, which is on the next slide. Thanks. So this is showing that we can predict Fisken properties, not exact values, but within certain range of the quantiles. And what we have in the x-axis, the virtual materials, graphene oxide functionalized with certain chemical structures from the database, which are all similar to glucose, let's say, in this case for demonstration. And on the top axis, on the top chart, we see that demonstrating we could also predict not only Fisken, we can predict ecotoxicity properties, for example. And this is based on the data which we found in the REACH dossiers, even if they are not, they are graphene in the REACH dossiers, but not all this functionalization. So we have these methods under development, not yet with user-friendly interface, but this is the goal is to enable this for you. Next slide, please. And as I said, we use data also from REACH dossier. We have existing workflow converting the freely available data from ECHA into the same data model as we use for Nanomapper. And there is, if you're not aware, there is a LRI Ambit tool, which is online since 2016, which was developed under Cefic LRI contract and is still being online and updated. And now we are trying to combine this huge amount of data with data from the nanosafety data interface. Next slide, please. This is how we can now represent a huge amount of data in the REACH dossiers in a data map, similar to what I was showing with the graphene functionalization case. Basically, the idea here is each substance gets its own point on the space, and if 2 points are close, then they are similar. And in REACH dossiers, there are a lot of complex materials and not well-defined one like UVCBs. So this is also shown here on the screen. We could devise different maps depending on the subset of properties of interest, and then enable similarity searches like in next slide, please. So this is again a demonstration that we can have different types of similarity defined based on data from combined databases. And this is also a tool which is under development and will be available in Nanomapper nanosafety database interface. Thank you. This is my last slide, and I'm happy to take questions after all the presentations.
Thank you, Nina. Then let's briefly wrap up what we just heard. So on the right-hand side, you see a diagram of the project as it stands now. And we've mainly focused what we just heard. Look at the boxes 4, 5, and 6. So the safe innovation approach with the user-friendly tools and the decision support system in 5. And then in 6, we have the case studies, which will be used to validate all of this. And at the bottom, you see the eNanoMapper Data Hub with implemented tools for similarity assessment and multi-scale modeling. One more or two more highlights at the top. You see that we have IATAs, so integrated approaches to testing and assessment. This is a feature which is specific for HARMLESS. We are trying to identify the mode of action, MOA, for a specific type of material using high throughput in vitro screening, for instance, and then perform omics analysis to understand the mode of action, or also just the so-called adverse outcome pathway, which is a kind of coarse-grained understanding of the mode of action. That is quite unique, but I think for these complex materials, this is promising because if you have mixtures of things, it's really hard to decide what drives the overall toxicity or hazard. So I think we will have to go in the biological system to understand this better. And then on the left-hand side, just at the top, you see that we identified 32 adverse outcome pathways, which are published, not from us, but 25 of them are on human health and 7 are on ecotoxicology. And to also facilitate the data richness of the material you're interested in, we develop new approach methodologies. So these are in vitro, cell-based or non-cell-based, or computational in silico models. And they focus on hazard, exposure, internal dosimetry, life cycle analysis, and ecotoxicology. Yeah, and in the end, of course, we want to translate that with multi-scale modeling like QSARs or AI-driven approaches, as we just heard, and we do the in vitro in vivo, hopefully human also translation of what we find in that. Yeah, that was kind of the overall summary now also. And with this, I would like to open the question and answer part. So you're welcome to share your questions with us. To do so, please raise your hand or write in the chat with a question mark at the beginning, or just put the question mark there and we call on you. And of course, when you speak, please turn on your camera, otherwise keep it off. Are there any questions?
This is Michael here.
Hey, Michael.
Yeah, just maybe a question to Susan. Maybe people are curious when this decision support system could be available.
Yeah, it's currently, of course, it's under development. We want to incorporate everything that was just explained by AdMa that's being developed within Harmless. So it will be become available at the end of the project. At the moment, we're testing it internally, as you know. Yeah, so it will become available at the end of the project.
So earliest 2 years from now?
Yeah, we have to see if we can come up with already earlier access to test it, but that will be, for example, for interested parties. So for those people who are listening and who are interested in testing it, so please let us know, and we can make it available for people to test it at a later, earlier stage than at the end of the project, of course. But the final decision support system, of course, we want to incorporate as much as possible. So that will become available at the end. But before, you will have earlier versions for which we would love people to test and get access to, provide access to.
So since we're running a little late in timing, of course, we will answer questions if you have any, but I would like to come to some closing remark in order to make sure we are not losing people who actually should and want to stay longer. So you can get in touch with us. We will send out an email to you where you get the slides which we've shown, plus the recording semi-complete. As you heard, we had a little bit of an interruption in between, but you can also use this contact form. I think the link is there in this email which we sent out to you. What we are really interested in is, I told that at the very beginning, so this will only be useful if it is used in the end, the whole system which we introduced. And for that, we would like to welcome small and medium enterprise users right now to get in contact with us with specific questions, specific products, specific materials, ideas, what they want to do. And we will then try to approach you in the way you need it, yeah. But we don't know exactly what that is. So I would encourage you, if you have a potential candidate for us to consider in our safe and sustainable by design system, please approach us. Let us know what it is, and then we get in touch with you and facilitate the next steps. And for that also, we have another half hour reserved just now. And discuss first things right at hand while we're here. And in fact, I think the official part is closed now. So if you were just interested in the presentation of the safe and sustainable by design system introduced by HARMLESS, this will conclude this part. And I would like to now encourage you, specifically the small and medium enterprises, but also point on that, also the consultants working in the safe and sustainable by design arena, to stay around, because we as HARMLESS believe that small and medium enterprises will have a hard time to really go by themselves through all of these endeavors. And a consultancy is probably a good way of navigating through the complexity of this issue. So I think we need consultancies also on board. So I would medium enterprises to stay on for a more kind of smaller group, informal discussion, and get together and just get to know each other a little better. So with this, I would like to conclude the first part of the meeting. Thank you very much for being here. It was a great pleasure to